So quickly, we're going to take a look at a little bit of grouping factoring review, and then we'll jump into our new factoring. Step one, anytime you are asked to factor, always look for a GCF first. Looking at my first term, which is only a variable, and my last term, which is only a constant, I do not have a GCF. So, on to factoring by grouping. Remember, when you have four terms, you're going to want to check for grouping first. Now, as we continue to learn more ways to factor, not every time we see a quadnomial will it factor by grouping, but you should always check first because it's easier than the other type of factoring that we're going to learn for a quadnomial. So, group your first two terms together. GCF is x squared. Divide that out, we get x minus 3. Grouping our second two terms, our GCF is negative 4. Remember, when we divide by negative 4, we get a minus 3. So keep track of your signs. If those binomials that you get once you factor by grouping don't match, go back and check your work. But remember, it won't always factor by grouping, so it may mean you have to try other methods. If they do match, use GCF to factor again. So this time, our binomial is our common factor. Dividing it out of the first term, we're left with an x squared. And dividing it out of the second term, we're left with a minus 4. Okay? So always, 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 when you think you are done factoring, ask if you can keep factoring. So quickly, I'm going to run through the list of the different types of factorings we've seen so far. We started with GCF. We already looked for one of those. Grouping. We already did that, and we don't have four terms inside either binomial. Difference of squares. We do have a difference of squares, x squared minus 4, so I'm going to keep factoring. And remember, a difference of squares you factor into conjugates. So let me remind you why this works. X times x gives us our x squared. The negative 2x plus 2x will cancel, and the 2 minus 2 will give us our negative 4. And quickly, the other two types of factorings that we've seen so far, if we have a trinomial, we can either try the t-chart if the lead coefficient is 1, or the AC method if the lead coefficient is not 1. Last slide, we're going to take a look at this new type of factoring, our sum or difference of cubes. Before we factor, always, always, always look for a GCF first. Well, in my first example, I've got my first term only variable and my second term only constant, so no GCF again. Cube root both terms. Write it somewhere that you can easily find the cube root without having to think about it as you factor, because you're going to be using the cube roots of each term to factor. Cube root of x cubed is x. Cube root of 216 is 6. If you don't have that chart, remember I asked you to memorize the cube roots up through 10. If you don't have that chart memorized, get it memorized. And then we're going to use our formula. So factoring our first term, or our first set of terms, our binomial, is just x minus 6. Use the same sign that you're given with your perfect cubes. Second set of parentheses, your trinomial, you'll take your x and square it. Opposite sign, so plus, multiply the two cube roots together, and then adding the last cube root, 6 squared. Now, what's nice about factoring a perfect cube is that that trinomial will not factor. So we don't have to ask ourselves, can we keep factoring? If you have a sum or a difference of cubes, you're done once you use this formula. Let's practice this a couple more times. Now we've got a sum of perfect cubes. Cube root of 27x cubed is 3x, and the cube root of 512 is 8. So, writing those using the same sign, 3x plus 8. Square the first term, don't forget the coefficient, so it's 9x squared. Opposite sign, multiply the two terms together, 3x times 8, and then add the 8 squared. And it's really nice that I don't have to check for factoring on this one because I don't want to have to multiply 9 by 64 and check the AC method. I already know with this formula, it won't continue to factor. All right, step one, always look for GCF first. 3 is my GCF, so I'm going to factor that out. Now, anytime the power on the variable is a multiple of 3, it is a perfect cube. So looking at 8 is 2 cubed, x to the 6th is x squared cubed. You just divide the exponent by 3. And then 1, of course, is 1 cubed. Don't lose your GCF as you factor using your perfect cubes. So then we're going to take 2x squared and square it. Don't forget to square the coefficient. Multiply your two terms together. Sorry, I completely forgot my first binomial, and that was a much bigger eraser mark than I wanted. This is the 3rd or 4th time I've recorded this, so even though I just made a mistake, I am not starting over. So we're going to do 2x squared plus 1 for our first binomial. And then in our trinomial, we're going to take the 2x squared, not forgetting to square our coefficient, opposite sign, multiply the 2x squared and the 1, and then add 1 squared. And again, we are done factoring because we used that formula. One more. We have a GCF on this one as well. We've got a GCF of 2x, so I'm going to factor that out, leaving us with x cubed minus 64. Those are perfect cubes, so taking the cube root of each, I got x and 4. So not forgetting my binomial this time, it's x minus 4, keep the sign in the perfect cube, x squared, opposite sign, multiply your x and your 4 together, and then add your 4 squared. Your U-try problem.